Hi, in this video we talk about our Python project. Firstly, we'll discuss our goal. Next, we'll talk about our progress and challenges faced so far. And finally, we'll talk about our future plans. Our project is road detection in massive LiDAR data. LiDAR, which stands for light detection and ranging, is basically a remote sensing method that uses light in the form of a pulsed laser to measure ranges of variable distances to the Earth. This LiDAR data is stored as LAS files. The basic goal of our project is supervised machine learning. Initially, we would be given a set of LiDAR data and the corresponding road network map for a particular region. We would try to identify certain points from the road network map and locate the same in the LiDAR dataset. After locating these points in the LiDAR dataset, we would analyze the data and try to extract various attributes related to the points located. We would also analyze LiDAR data where road is absent. Once the analysis is done, we would train the system with various attributes of the LiDAR data for both absence and presence of the road. Finally, using this learning, we would predict the road network for a different region from the LiDAR dataset of that particular geographic region. As for the challenges faced so far, the majority of our time spent was on installing liblas library. Liblas is an open source library for processing LAS files. The liblas Python package was dependent on the liblas library, which in turn had various dependencies on other libraries. What we have mainly done so far is that we have focused on processing the LAS files using liblas. The header part of the LAS files contains various informations such as the number of data points the LAS file has, minimum and maximum values of the XYZ coordinates, and so on. The attributes that each point in the LAS file will have depends on the data format ID. If the data format ID is 2 and above, then all the LiDAR data points will have color attributes. We have created a Python module which takes LAS file as input and processes and creates an image file. Let us show an example for the same. The Python program takes the RGB values of each LiDAR data point and colors the corresponding pixel of the image with the same color as in the LiDAR data point. There's also a provision in our module to look into particular rectangular region of the LiDAR dataset by providing the top and bottom coordinates of the diagonal. As you can see, we are inputting the coordinates for the diagonal . After the coordinates are entered, when we run our program, the image file would be generated for that particular segment, as we can see on our screen. Now, all the points in the LiDAR data is stored in an UTM coordinate system where XY coordinates represent a particular point on the Earth. We have installed GDAL library for converting the XY coordinate to the corresponding latitude and longitude. So our next step is to process shape files so that we can map the road network data to corresponding LiDAR data in order to train the system. Thank you.